Hello everybody, it is Brian here from quantlabs.net. I wanted to show you some tricks I've learned through the Matlab and some Matlab webinars. If you're learning Matlab, it's a good way to learn about Matlab is through the webinars. They're quite useful. You can see some real world examples of some of the people that work at Matlab and how they use it. So anyways, I've gone through it. What I'm trying to achieve right now is the ability to be able to use Matlab, build, let's say, a Matlab trading strategy in their Matlab M script or scripting language, be able to somehow translate it or be able to have a C++ application connect to it. I've found that the other advantage with what I'm about to show you through the Matlab Compiler is that there's virtually no limitations on doing this. So let me give you an example of what I mean. Okay, so there's two pages that I can direct you at. One for, heaven forbid, if you're on Visual C++ 2005. I'm going to assume most people are on Visual Studio 2010. Let's come to this URL, follow the instructions. It does work, but there's some big caveats that's not really mentioned here that took me hours upon hours to figure out. First of all, here is my Visual Studio, and here is my Matlab. Okay. What I want you to understand is, if you come under your About Matlab, you got to know if you're dealing with a 64-bit or a 32-bit version of Matlab. When you follow these instructions, basically I'm going to, again, just follow the 2010 edition for Visual Studio. What you'll do is you'll build your M script here. Which is it? Yeah, so you build your M script right here, called whatever, foo or whatever, and then you compile it using this command right here. What it'll do is it'll create these files, including your library and your DLL. Now, again, you got to realize, depending upon what version, that could be either 32 or 64-bit. Alright? So that's one big caveat you need to be aware of. Also, when you come in and you build your Visual Studio project, they all tell you to do Win32. You obviously need to have that Visual Studio project match your 64-bit or 32-bit. So in essence, if you come under the Visual Studio, you look under here in your release or debug mode and make sure it is 64-bit. If you're using, let's say, a 64-bit version of Matlab, because you want to obviously match up your 64-bit libraries and DLLs with your project from Visual Studio for C++. Make sure it's 64-bit, because if it's not, you'll get unresolved externals. Now, there's another trick to this as well. So you bang out your code, it's the exact same as what you'd have in this link here. But one of the other caveats with this is right here, this path. This is where you locate the libraries for Matlab so that the Visual Studio uses as part of the Matlab dependencies for your Visual C++ projects. One of the other things that you need to be aware of is, alright, let me just show you the path, or let me just show you what it says. Essentially, it'll tell you that it uses Matlab root, external, lib, and whatever the archive of Microsoft, okay? And it could be a variety of different ways. Now, let me just show you what we got here. At least this version of Matlab that I'm using. Alright. So if you come under the Matlab programs, just find a good way. Okay. So here's the thing. Come in your program files, MATLAB, and you have now MATLAB compiler runtime and or just the regular version 2011A in my case. If I follow this URL, this throws me off because I'm thinking I'll go to this one. I'll follow this path. So I'll be under the MATLAB R2000A, and I'll come under here, under this lib, Win64, boom, 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 boom. Well, guess what? This library that you need, that they claim that you need, this MCL, MR, guess what? Obviously, this library doesn't exist under this path. But as you come under the MATLAB, you don't go under the release 2011, follow the MATLAB compiler runtime. And you go under your lib. Or which one was it? Yeah, here. Which is good that I'm showing you this. See here, let's include see here, right here, this is the foo lib that you just built with the compiler, the MATLAB compiler, and this one's the MATLAB libraries that you need, but you need to follow the MATLAB compiler runtime, your version, your external lib, basically meaning version. Remember, I'm following MATLAB compiler runtime, version 715, external lib, Win64, Microsoft. You follow this one. Why? Because this is the library that you need, in which this document is saying that you need. So you need to ensure that you follow that correct path, and hopefully you can figure it out on your own. But it took me a little bit to figure that out, so that's another caveat. Once that's found, everything should compile and build. In my case, it does. Well, let me just rebuild it just for fun. Okay, there you go. One succeeded. Sometimes, if you can't find that MSCRTL whatever library, this guy, it's going to throw obviously unresolved externals. So now I have a one successful build. I can run it. Oh, and other thing as well, under your Visual Studio project, under the release, because it is a release mode, make sure you throw the DLL and the library into the runtime path, okay? And guess what? It works when I navigate to that same release directory. Boom. Okay, so one thing I need to also mention here is you saw that little bit of the delay. Boom, there's a delay. That delay is because what's happening is when you initially call the MATLAB compiler runtime, it takes a couple of seconds for it to initialize. Okay? It's no different if you were to click on your MATLAB. You'll see how long it takes to execute. So it does need time to initialize the MATLAB compiler runtime, or the MCR, and then once you start calling your MATLAB functions within your MATLAB compiled library, everything should be the same performance that you'd get as if it was under MATLAB itself. Alright, so what does that mean? Now that we're going using the equivalent of a MATLAB coder, or in my case I might go with this MATLAB compiler route, which is maybe better. And here's why it might be better. If I go into MATLAB, I go under deploy, or actually right here, this is my project, okay? If I come under settings, what you'll get, look at this, toolboxes on path. This is where all these toolboxes are included. The key one for me is this one right here. It's a parallel computing toolbox. What does that mean? Well, now I can develop all my trading strategies, okay, all within MATLAB, and at the same time develop the same MATLAB code calling through the GPU toolbox. So that means I can run as if I'm running in the MATLAB environment, headless version through this headless MATLAB in this compiled library of MATLAB. I now can call my GPU or CUDA calls through the MATLAB compiler and call all these parallel computing toolbox. So that means I still need to further test it and further confirm the performance of it. But if that's the case, there's two advantages doing it this route. The first advantage is that obviously if I have the capability to run GPU through the MATLAB compiler, through a static C++ library that C++ file can call, that enables me to access the capabilities of my GPU or my CUDA board through that route. So that means that I do away with all the hairy, complicated C++ code that will, from what I'm researching, will make you tear your hair out with the CUDA library. It's just like those calls are very are not that easy to use. Also, because I'm using the GPU, and hopefully I'm using the GPU through the MATLAB and through this MATLAB compiler business, that will obviously speed up my processing immensely. And again, as I said earlier, if I go this route using the MATLAB headless version through the MATLAB compiler, the performance will be the same as if I'm running it within MATLAB itself. But it's kind of interesting. This might be the better route. So I'm doing away with the complexities of going through the MATLAB coder. Instead of I can get access hopefully to a majority of all the toolbox functionalities and functions for all the toolboxes, as I said, also including that parallel toolbox one, or parallel computing toolbox. So that's what I'm hoping. I just want to put this video together for two things: to show you how to use MATLAB Builder to build a library for MATLAB and have that get called from your C++ application, obviously a trading platform. Also, I wanted to show you that if you do go the CUDA GPU route, this is probably a really fast way to get access to two things: developing a strategy, and at the same time being able to use the capabilities of your CUDA board all through the easy coding of MATLAB instead of, as I said, doing it directly with C++ and the CUDA library. Hopefully that will give you a better synopsis on what I'm thinking of doing and making my life a lot easier. And I'm hoping that the performance is still as good as if I was to go through the coder and bang out the C++ code from the MATLAB coder, and then at the same time I have to go through the however means to take that MATLAB C++ code and then transform it into making it compliant for the CUDA board or the CUDA library. So I'm hoping this is the easier route. So that means I can get the HFT platform built a lot faster, and at the same time it makes my strategy development a lot easier and a lot faster and a lot less messy, as opposed to using some unknown packages from R, let's just say. But this may be a good path to play with, at least for now. And hey, if a year from now I'm making good money and I can actually get myself a full-on copy of the coder for whatever version it will be, I could do that. But for now, this might be the best way to get up and running as fast as possible, and making life easy for myself and whoever's going to maybe follow this path as well. Hopefully that will help you out. Talk to you later.